Okay, students, so we're here with the Unit 9 test review. All right, so let's just dive right in. Research was collected on popular selling concession stand items along with what combinations people preferred to get. All right, what is the probability that someone got a hot dog or a soda? All right, so what's the probability that they got a hot dog or soda? All right, because remember, or means union. All right, so to be very mathematical about this, we use the addition rule. Probability they got a hot dog plus the probability they got a soda plus the probability, or minus they got both, because we don't want to double count. All right, so hot dog. All right, how many people got a hot dog? 158 out of 400. All right, how many people got a soda? Plus 200 out of 400. But can you see that we counted this 50? This 50 for this hot dog and soda was included in both. So we got to subtract 50 because we double counted that. So we got to do minus 50 over 400. All right, that's it. All right, then you just got to compute the number. So it's going to be over 400. Remember, when you add and subtract fractions, you keep the denominator. So it's going to be 308. 308 out of 400 people got a hot dog or a soda. All right, and let's get that as a decimal. So that equals 0.77 or 77%. So at this concession stand, 77% of the people got a hot dog or a soda. All right, now let's just dive right into the next question right here. So what's the probability someone got a hot dog and a soda? All right, when you see the word and, that means intersection. All right, so they need both, and it's really bada bing, bada boom, that right there. It's 50. All right, it's 50 out of 400 people, which let's get that as a decimal, 0.125 or 12.5%. So kind of interested in to see these problems back to back. 77% of people got a hot dog or a soda, but only 12.5% got both. All right, now let's just keep going right along. So we can look at some notation. What's the probability that someone got a pizza given they got no drink? All right, probability they got a pizza given no drink. All right, so we can be super complicated and use that formula we were talking about with conditional probability and all that stuff, or we can just be able to use common sense and interpret the table. All right, given they got no drink, so that means I'm very concerned about this column right here. All right, now how many people got a pizza given they got no drink? It was 4 out of 60, which is about 0.067 or 6.7%. All right, what's the probability that someone got a pizza? Well, let's look at that. Pizza, 182 out of 400. So the probability of just a pizza is 182 out of 400. All right, 182 divided by 400 is about 0.455 or 45.5%. All right. So what can we conclude from the results in Part C and Part D is a bunch of ways to go about it. We can just say people who got no drink are less likely to get pizza. All right, because 45.5% of the people got pizza, but only 6.7% of those with no drink. All right, so if you got no drink, you probably weren't getting pizza. You're more likely to get a hot dog or even no food. All right. So just looking at some tables, interpreting it, looking at it different ways, so on and so forth. Let's just go to the next problem. Amazon conducts a random survey of its customers. All right. This Amazon comes to my house just about every other day. My wife's always buying something from them. All right. I think Jeff Bezos has my address memorized. The survey shows that 60% of the customers receive their purchases on time. So let's say 60%. This is going to be some chicken scratch on time. That means 40% did not. Of those customers that received it on time, 80% were satisfied with their purchase. That means 20% were not. All right, what percent of customers received their purchase on time and were satisfied? All right, so it's not just a simple 80%. We got to multiply these percentages together. So the probability of on time and satisfied is going to be 0.6 times 0.8, and I translate it to a decimal. It's going to be 0.48. All right, that means as a percentage, you just multiply by 100, it's 48%. So in this problem right here, you just take it as a decimal, multiply them together. 48% of all customers received their package on time and were satisfied. All right, and that's that problem right here. And then one more problem for this video. Charlie has a bag of mixed candy mixed with M&Ms and Skittles. He has 37 M&Ms, 21 which are red, and 16 orange. He has 43 Skittles, 5 are red, 30 are orange, and 8 are blue. Determine the complement of each event. Charlie has an orange M&M. All right, the complement of this, well, Charlie has an orange, so it can't be not orange M&M. All right, so the complement would be everything that's not an orange M&M. All right, so what this would be red M&M or Skittles. Could be any Skittles. All right, so it just has to be not a red or not an orange M&M. So it could be the red ones or just Skittles in general. That's the complement, because that means not. It fills up the rest of the sample space. All right, and let's even say that complement fills up sample space, and remember that's up to 100%, or I also like to say not. All right, that's it.